Okay, we're going to have a look at ionic bonding. First three slides you need to know before we start. Atoms generally want to have a full outer shell, which makes them more stable. They either lose electrons or gain electrons. You've got to know the valency table, and you've got to know the ignore the signs, swap them over, drop them down, simplify to work out the formulas. If you don't, pause on any of those slides, and you can go back to those. Okay, first of all, dot cross diagrams. Here's an example. Sodium, it's in group 1 of the periodic table, so it's got 1 electron in its outer shell. Inside, we haven't shown the other electrons, 1 electron in its outer shell. And we've got a chlorine atom, and again, it's in group 7, so it's got 7 electrons in its outer shell. We haven't drawn the inner electrons, 1 chlorine atom. And you'll see that sodium wants to lose an electron to get a full outer shell. Its inner shell will then be full. If it gives that electron to chlorine, this shell then becomes full. So we end up getting something like this. There's your sodium plus 1 ion. It's plus 1 because it starts off being neutral here. It loses a negative charge, which leaves behind a positive charge. Chlorine here starts off as being neutral, but it gains an electron. It gains a negative charge, which means there's the extra electron it's gained, which means it's got a -1 charge. So we have a chloride -1 ion. So sodium has 1 electron in its outer shell. Chlorine wants to gain that 1 electron, and both ions end up having full outer shells. You'll notice here a +1 charge and a -1 charge, and that's the attraction between the +1 and the minus is the ionic bond which sticks these together. Here's another example. Magnesium has is in group 2, so it's got 2 electrons in its outer shell. If it reacts with fluorine, fluorine's in group 7, so again it's got 7 electrons in its outer shell. Notice again I haven't drawn the inner electron shells. Now here, that magnesium gives away 1 of its electrons to fluorine, so fluorine gets a full outer shell, but you'll notice there's 1 electron hanging around spare. That electron has to go somewhere. Where's the only place it can go to? To fluorine, to a different fluorine. So both fluorines end up getting full outer shells. That looks like this. Magnesium has lost 2 electrons, so it gets a 2+ charge. And then fluorine gains an electron from magnesium to form an F-1 ion, and then the same happens again. So we have 2 F- ions. Magnesium's got 2 electrons in its outer shell that it wants to lose. Fluorine wants to gain 1 electron, and we end up, because there are 2 electrons to be received, 2 fluorines gain those, resulting in 1 Mg+2 and 2 F- ions. And you'll notice that all ions have full outer shells. Last example, aluminium is in group 3, so it's got 3 electrons in its outer shell. Oxygen is in group 6, so it's got 6 electrons in its outer shell. Aluminium wants to get rid of 3 electrons. 1 goes to the oxygen. Another can also go to the oxygen, but that's oxygen full, and aluminium wants to get rid of an extra electron. Where does it go? To another oxygen. But you can see there's space now for another electron. What gives away electrons? Well, of course, aluminium does. So aluminium gives another electron away. And that's still a problem because we've got 2 electrons here and they need to be given away. Where do they go? They go to another oxygen, and eventually we find that the combination of 2 aluminiums and 3 oxygens works. That produces something that looks like this. Aluminium has got rid of 3 electrons, so it has a 3+ charge when it's got rid of those 3 electrons. And of course, we've got 2 aluminiums. Oxygen, each of them receives 2 electrons from aluminium. So we end up having 2 Al3+ ions and 3 O2- ions. In this case, we need 2 aluminiums giving away a total of 6 electrons, 3 oxygens receiving a total of 6 electrons. That's why the formula of aluminium oxide is Al2O3. Hopefully that all makes sense to you.